Welcome to the On-Premise IT Roundtable podcast, the only show that dares to be both on topic and usually on location. Each time we meet, we bring together a set of IT luminaries to discuss a single premise or concept. In this episode, we're talking service mesh. And frankly, service mesh is a solution in search of a problem. Or is it? Or does service mesh have a use? We'll find out in a minute. First, let's meet who's on the panel today.
I'm Calvin Hendryx-Parker. I'm CTO and co-founder of 6 Feet Up. I'm looking forward to discussing this one.
I'm Ned Bellavance. I run Ned in the Cloud LLC, and you can find me at nedinthecloud.com.
Hi, I'm Jason Benedicic. I'm an independent consultant from the UK. You can find me at thedatacenterbrit.co.uk.
So we are here this week. Actually, it's NGINX Sprint is this week, and the four of us have all been paying attention to the NGINX presentations. And, you know, this isn't really directly related to NGINX as much as it is to modern application development. Everybody keeps talking about service mesh this. Everybody wants to be the service mesh. And I can totally understand why a product company would want to be the service mesh for the enterprise, right? So just to kind of level set, a service mesh is essentially a dedicated infrastructure layer that allows service-to-service communication between either regular services or even microservices. And typically, it looks like a set of network proxies that allows you to do up, down, left, right, north, south, in, out communication between containers. Is that right? I mean, Calvin, do I have service mesh right?
I mean, as far as I understand it, service meshes to me sound a little bit like magic that's just sprinkled on top, and magic is going to make all of your problems go away for deploying these large, it sounds like large applications. But again, I'm not the service mesh guy probably here. I may let some of the other ones give a better definition than I can.
I don't know if I would call myself the service mesh guy, but I have been involved in deploying one or two and talking to some folks about it. I think actually instead of a top-down, it's almost more of a bottom-up, because the way that service mesh is typically deployed is by adding a sidecar to your existing container or pod deployment. So it's actually sitting at the bottom, hanging with all the applications. And then there's some sort of control plane that's the magic over the top that's talking to all of these proxies. Well, actually, what's even more interesting is the proxies reach out to the control plane. So it's not even a push, it's more of a pull type architecture. And yes, then magic does in fact happen. So that portion of it, Calvin, you are correct.
Yeah, and I think, you know, just to sort of add a little bit more spice in there, I guess there's not just the proxying of traffic, it's discovery, it's inventory and understanding, you know, when new services come online. Don't forget that we're talking about sort of stateless and scalable infrastructure. You know, something has to coordinate the fact that you just brought 10,000 new containers online, and that's kind of where the virtues and benefits of a service mesh is promoted. Whether that's the best way or not, we can get into, but that's kind of where the promotion of this technology stack is coming along.
And let's follow on that by talking about sort of the purported benefits. So why is it that companies want other companies to adopt a service mesh? What is the purported benefit that a company is going to get from a service mesh architecture?
Sure, I'll take that one to start with. I think the biggest benefit is to larger enterprises that have a bunch of different applications teams or a lot of microservices that need to talk to each other. And the problem you quickly run into is not every application team is going to necessarily want to use the same stack, use the same proxy, use the same networking operations. They might all have their own ideas. And you might want a way to standardize at least the networking portion of things in the same way that you wouldn't want to, you know, string together an IPX and AppleTalk and a traditional IP network together. That sounds like a mess, and it was. Instead, let's standardize on one of those. And the service mesh is like that other layer where it brings some clarity to all these different services that are out there and lets them talk to each other in a secure way. And the other thing I'll say is it brings an operational consistency for those who want to operate, and also gives security and compliance some levers to say, hey, here's a policy that we've defined at the service mesh level. if you want to add your service into our service mesh, you have to be in line with this policy where you have to really define what ports it's going to talk to, and also, ask for permission of what other services it should need to talk to within the cluster or outside of the Kubernetes cluster. So I think those are the major benefits, is to large enterprises that just need to rein in the chaos a little bit.
Yeah, but I love the fact you brought in the blast from the past with the Apple Talk analogy there. But I still think that you're getting such an overhead and an added layer of complexity you're putting on top of this. I just wonder if is the productivity boost or the chaos reduction tamping down, worth going with this extra complexity of the service mesh. Feels like if you had software developers running, even using different technology, different stacks, different proxies, whatever they wanted to use, if they were running like independent enterprises inside this one enterprise, I see a benefit there is you probably get less decoupling. You probably have less trouble upgrading and modifying one portion of that stack or a silo of software than if you're running in that service mesh and developers get it lulled into that sense of comfort. Are they not going to start more tightly coupling some of those services? Are we going to see dependency issues as they go to upgrade one piece of that stack over another piece of that stack? I just worry we're shifting chaos from like one part of this stack to maybe another part of the stack. And as more of the developer guy, typically on these kinds of panels, I feel like I don't want to take that complexity. I'd rather run my operations in a clean, effective way, publish what my interfaces are going to be, stay less decoupled to those other services.
Yeah, I'm on the same sort of wavelength as some of this, and I believe that we're at risk of entering a kind of a period of engineered complexity because we're being told that complexity is what makes modern applications. And that's not necessarily the case. We're not all the next Google. We're not all the next Netflix, or we don't need to generate the Borg. That's not the goal. And there's a lot of companies, there's a lot of products out there that are telling you that to be successful, that the next thing you need to do is to build these microservices and build these service meshes, and you must use Kubernetes and you must use all of these things. And yeah, there's a lot of complexity that gets added because we're told to add it. And is that beneficial?
Absolutely. I think there's definitely a trade-off here. That's what you always got to keep in mind, is complexity is fine if you're getting benefits from that complexity, but the trade-off is the complexity, the additional administrative overhead. And for a small organization or a startup that has one application, they may not need a service mesh. They may not need Kubernetes. They could run everything serverless on AWS to start. And then when their application is a runaway hit and everybody loves it because it's, Twitter for canaries, and suddenly they have to scale like crazy. Okay, now's the time to re-architect your application a little bit. Hopefully you got some VC funding, so you're in good shape from a financial perspective. All right, let's figure out how to break this application apart. And that's when the service mesh might come in. And we've been talking specifically about containers. I think that's been leading the conversation because everybody makes that connection between service mesh. Oh, Kubernetes. That's what the two are. But really, a service mesh can extend beyond Kubernetes to virtual machines or even bare metal servers. And on the other direction, it could extend to serverless. So if we think about it that way, a unified sort of data plane and a unified control plane, that sounds like an interesting prospect. And one of the things that I thought was really cool is that it adds in the idea of MTLS for everything. So when your services are just talking to each other across all kinds of potentially unsecured networks, wouldn't it be nice if all the services just immediately had TLS out of the box and you didn't have to think about it and your developer didn't have to think about it? I kind of like that feature as well.
Yeah, I think I like that one aspect of it where you have those guardrails and the convenience. I think during the last talk at the Nginx Sprint, they mentioned that having that level of convenience where developers can not have something standing in their way, but then still those guardrails of, well, I'm not sure what the best practice is for a thing. I'm just going to throw something up there. Well, we could rein you in a little bit on that one. So I do see that aspect of it where if you're not sure how to do a thing in your org, there's going to be a standardized doc, but you could have that standardized doc either way. I don't think this is specific to service mesh, and I think maybe this is just a band-aid on top of poorly run engineering organizations who have not standardized their own operations. I think DNS does a fine job of letting me look up the names of services that are on a network.
Sometimes it does, and sometimes DNS can't keep up with the short-lived nature of microservices. If new pods are spinning up and you're spinning up and spinning down a couple thousand every 10 minutes, DNS and TTLs aren't going to keep up with that. So you need a more programmatic and sort of synchronous approach to it. That's definitely a concern that I would have with using something traditional like DNS.
I think the thing is there's many solutions out there, right? You can use open source, you can build your own. There's solutions for all of this. I think one of the things that I took away from the Nginx Sprint talks today was that you don't always need to build it yourself. Sometimes you want community wisdom. Sometimes you want that engineered experience of somebody that's been there, they've been through the pain. They've realized that putting in the thousands and thousands of DNS changes isn't going to work. And, the guardrails are in place. The reference architectures are in place. If we can tamp down that complexity into distilled community wisdom and say, right, if you want to run this kind of application, this is how you do it. Maybe the evolution of service mesh is that we have lots of known application profiles, and you just apply predefined profiles to your mesh and say, you're going to run this web application, you're going to run these databases, you're going to run these middleware services, and it builds it for you. Couldn't that be the great next thing?
I think the great next thing is that most applications that are probably on a service mesh are probably behind a firewall and internal to these enterprises. I don't know how much scale some of those applications really need. It still could be overkill, even in a large org, for a small application to be deployed onto one of these service meshes. I think that you can go a long way with Terraform, Kubernetes, containers, just the bare bones basics. And as I always tell everyone who I consult with is don't go any more complex than you have to launch anything, because you'll get buried in those details and it'll never take off the ground.
Well, it's like that for, honestly, for everything, every choice you're making, you have to decide, am I going to get benefits from this, or is this just going to make everything more complex? And it's that old saw in the cloud space, in the application development space, where you say, look, you're not Google, as we heard before, you're not Twitter, you're not Facebook. Do you really need something that is as scalable and as flexible as one of those hyperscalers needs? Or, if you've got a fairly consistent application with consistent services, maybe you don't need that kind of dynamism and flexibility. But I could see that there could be a point where future applications might actually require a service mesh type infrastructure to run. Am I wrong? I mean, is this something where companies are going to find that they're going to need this in the future in order to keep up with the sort of state of the art of containerized microservices applications?
So let me just posit a theory here in terms of how we approach networking and security today versus how it could be approached in the future. This is something I've had some conversation with some other folks about this. Typically, when we try to segment out our network today on premises, we're doing that by segmenting it into subnets and then putting a big honking firewall between all of our subnets. And then we got into okay, now we're going to segment it down more into microsegmentation, but that's still not widely deployed everywhere. To a certain degree, service mesh can help provide extreme microsegmentation all the way down to the application layer, almost the process layer. And by doing that, you can now apply the same security and networking model to your on-premises network as you would to a cloud network, as you would to a non-network where you're just consuming services as opposed to mapping out an IPv4 or IPv6 network. So that's where I see service mesh evolving to, is hey, I do need to connect all these things together, but doing it the traditional way by paying $100,000 for a firewall that has 10 gig of throughput, that doesn't make sense to me. I already have a network that can do 50, 100 gig. Why am I putting this huge bottleneck in the way? Let's distribute that out to the endpoints, and service mesh is the way I'm going to do that.
Yeah, but I think if your application is dependent on a service mesh to run, I don't think it's been designed well. I feel like there should be multiple operational modes for any of these applications you would deploy, and containers kind of being I would love that to be just the de facto standard for deploying a function as a service or deploying a full-blown business application, is that I can point that container or image into a cluster someplace and I have my application running, but I don't have to do it that way. I could still spin up, container D or, some much more lighter weight option to get this running at an edge node a lot quicker than having to deal with, maybe all those complexities. So I don't think it's a hard requirement, but I think people should be designing applications in a way that's maybe you have to think, the developers have to think a little deeper about how they're building these applications so that they can interoperate and work on a service mesh, because they may need that. But if they don't, we don't want to enforce that as a hard dependency for applications to deploy.
Yeah, kind of feel like don't want to sit on the fence, but I'm somewhere in between in that we've got more locations than we ever had. We've got more types of networks, more types of deployment scenarios. As Ned was saying, like on premises, the cloud. We've got edge devices. Edge compute is becoming a big thing with more IoT, with 5G, and I don't want to use all the buzzwords, but you've got AI, ML processing that people are doing everywhere. People are doing a lot more, and it would be nice to have that ability to have a singular set of policies that work no matter where I've deployed it. And I know that my application is going to conform to those policies, that the security is baked in, that the discovery is baked in. And I think that's kind of the benefit that we're seeing with service meshes here, is that you've got a bare metal component, you've got a virtualization component, you've got container components. It can work no matter what your deployment model is. And I think that's the benefit. And it's not got the huge expense of, ridiculously expensive firewalls. And I don't want to put a 10 gig firewall in the boot of my car when I can have an IoT device do the same thing.
Another thing that occurs to me, and I have to bring this up, being the grumpy old man yelling at the cloud, is that again and again, we see cloud people developing a solution for a problem that has already been solved by people who actually know something about that area. So whether it's storage and the bizarro universe of Kubernetes and container storage, or the exciting world of inter-container or inter-service networking, I wonder if perhaps somebody could have maybe leveraged the lessons of 40 years of enterprise networking instead of reinventing networking and creating a service mesh. That's my grumpy old man statement. Anybody want to take that, Ned?
Sure. Yeah. It's a legitimate concern, right? Are we just reinventing the wheel and not learning any of the lessons of the wheel makers before us who figured out like rubber's better than metal for, riding smoothly on a road? So we're beating it out of tin again. Okay. That's a problem. But I would also posit that to a certain degree, networking hasn't significantly changed in 20 years. So yeah, we can use those lessons that have been learned, but there also needs to be some advancement. And if the networking companies out there aren't going to do it, the major vendors, well, somebody needs to do it. And where did that come from? It came from the cloud native space and the cloud companies who said, yes, I know that that's the way it's traditionally done in the enterprise, but I'm not going to call out individual companies here, but networking industry as a whole, you haven't done much but give us faster pipes in the last 20 years. So now we need to layer some new technology on that lets us move the ball forward. And that's what they did. I'm not saying you don't need a reliable underlay for all of this. You absolutely do. But right now that underlay doesn't do anything else for me. Maybe it doesn't need to. I do need this additional functionality, the centralization of control and the distributed nature of the data plane. So I think in our case, the service mesh is doing that. Is that the end all and be all? Absolutely not. but it is at least a useful starting point.
And the important point to note is that some of these things never make their way to a network. I might have 100 containers on a host that never leave the host. The network team isn't going to give me anything there. The network technology isn't going to give me anything there. So we've had to augment it. We've had to come up with something else, especially when you're looking at functions or containers, because they run at such a small scale, and so many of them that we may never make it to a network to do the thing we want to do.
I think that does make a lot of sense when there's so many services or so many containers running even on one node and we're never hitting the network. I think this is a great opportunity because no one person or one developer or even developer team could keep all those things in their head. If all they have to do is say, I want to call out to the Redis service, I don't care where it lives, what it's doing, I'm down for that. I could definitely see that as being a valid, more than valid use case.
I think there can also be a feedback mechanism there where if the service mesh can emit monitoring and telemetry data about what containers and pods are talking to which ones, then that can feed back to the orchestration portion that can bin pack things to say, oh, I see these services tend to talk to each other. I will co-locate them on the same box to minimize latency. Hey, look, we just did a cool thing, and we didn't have to use some sort of crazy AI or ML thing to do that. We just literally looked at, oh, that talks to that a lot. All right, I'm going to schedule them together next time.
But shouldn't that be really the domain of just Kubernetes only? Or do I have to add on all this other stuff on top?
I think Kubernetes can handle the scheduling of it. But Kubernetes is pluggable in the sense that you can add your own schedulers that might have additional insight into what's going on and making use of that telemetry data. So in that regard, Kubernetes is responsible for actually scheduling this stuff, but the larger orchestrator who's thinking about, or I would say thinking in quotes, right? Oh God, we're getting into AI again. The larger orchestrator that's making decisions can use all of this additional information it's gleaning from the network. And what better way to do that than to tap into something that can see all of the network traffic at its egress points?
So an orchestrator of orchestrators.
So honestly, I hate to say it, but if the premise is service mesh is a solution in search of a problem, it sounds like the result is no. Service mesh is a very useful solution for very specific and growing problems. I'm going to give you guys each a chance to respond before we wrap here. Is service mesh a really great, awesome thing and people should have it? Jason, let's go. Let's start with you.
So it's definitely a great solution, but to a specific problem, and not everyone's going to have that problem. There will be a lot of people that become the next Uber or the next, Pinterest or one of those things. The cycle on these things is getting more frequent. So there are going to be huge scalable apps that come out, and even more so with distributed working and the way things are. I'm sure the rise of Zoom and Teams and things like that have scaled beyond what anyone ever thought. So it's a growing use case, but it is still a specific use case. I'm not going to go and use it for my website. I get a couple of hundred hits a month. It's no good for me. But if I was suddenly getting a few 100,000 hits a day, maybe it would be something that I'd need to use.
What do you think, Calvin? You on board service mesh?
Almost. I think I'm close. I think that we developers and application designers need to basically make sure their apps can upgrade gracefully instead of the degrade gracefully. If we can upgrade gracefully into a service mesh, I can start out simple, and that's where things got to stay. So I won't be like Jason. I probably won't be deploying a service mesh anytime soon. I think it definitely fits in a certain specific segment of problems and around scale. When you've got so many different services that have to coordinate, I'm game. But until we get to that level of complexity, I'm not adding another complexity on top of that.
Oh, I get to have the final word. I think both you gentlemen really hit the nail on the head when it comes to where service mesh fits anywhere. It fits when you have the problem. And it is a very specific problem that requires a solution. Now, do I think that it could be generalized and simplified to apply to more use cases? I think it could. I think if we're looking in the long term, the initial implementation was there to fit a specific use case that large scale enterprises with big microservices platforms that have a lot of churn had a need, and service mesh was the answer to that. That being said, now that the platform exists and people are actively developing on it, now we have the opportunity to simplify its deployment, make it something that more people can consume, and then maybe there's some additional utility that even smaller, used to be not use cases, will now find a purpose behind service mesh. So I think it's something that's going to expand and possibly merge with other solutions like a proxy or an API gateway.
Well, there you have it. I think we have effectively answered our premise, which is that service mesh is an effective solution to a very specific set of problems. And we are going to see it more and more, and it's going to be one of those parts of the enterprise infrastructure. So before we go, I wonder if I can ask you, where can we connect with you? Where can we continue the conversation on this or on other topics? Is there something you've recently done that you'd like to share with our audience? Jason, let's start with you.
Yeah, so for general conversation purposes, you can catch me on Twitter at @Benedicic, but also check out the latest Gestalt IT showcase with PlyOps. You can hear about some of the latest and greatest things in distributed storage.
If you would like to engage with me, the best place to find me is on Twitter. It's Ned1313. Should be easy enough to remember, right? If you wanted to hear more about this specific topic, I actually had a conversation with Matt Klein, the gentleman behind Envoy, on the Day 2 Cloud podcast. So you can check it out. It's episode 82, and you can find that at day2cloud, all spelled out.io.
If you want to engage with me, you can find me on Twitter as well. I'm CalvinHP. And I want to promote the Python Web Conference videos are now live on Twitter. So if anybody wants to go check those out, we had an amazing lineup of speakers, lots of great topics from DevOps to AI and everything in between. So check those out. If you just go search Python Web Conference 2021, those just released, and I'd love for you all to see them.
And as for me, I'm Stephen Foskett. You can find me on the Twitters as well as most social media networks at sfoskett. And I will just point out that we, as I mentioned earlier, we're just recording reactions and discussions about Nginx Sprint for the Tech Field Day event. So if you go to YouTube/Tech Field Day, you'll see a playlist there, or just techfieldday.com, and you can see deep discussions from the delegates and myself about the content of Nginx Sprint, including more details of some of the products that they're working on. You can also find me every Wednesday as part of the Gestalt IT Rundown, which is our tech news show. So please do go to gestaltit.com and check out the rundown every Wednesday for the latest tech news. So thank you very much, everyone, for joining us. It's great to have you. And thank you, everyone, for listening. If you enjoyed this show, please do subscribe. We love the fact that so many people subscribe and listen to the show every week. And also maybe drop us a rating or review in your favorite podcast application, wherever it is that you're listening. You can also share the podcast with your friends and find more episodes at gestaltit.com/podcast. Thanks for joining us, and we'll see you next week.